Hi boys and girls, this is the last day of your math packet. Remember, this is the last video. You still have week 8 in your packet, but we won't be doing videos for week 8. So this is the last page of week 7. There should be a snowflake with the number 14 in the top right corner. Remember, this is just a tool to help you. Do as much of this on your own as you can, and then check your work, check your answers. If you get stuck on any, follow along with me as I do it. Today we are going to do the division problem as a challenge. I know some of you can rise to that challenge. So today, even though it's an advanced division problem, we're going to be doing it as a special challenge. Let's start with number 1, finding the sum. Sum is the answer in addition. 7 plus 4 equals 11. Put your 1 down, bundle the other 10 ones, and move it to the tens place. 1 plus 9 equals 10. 10 plus 4 equals 14. Write down your 4, bundle the other 10 tens, and move it to the hundreds place. 1 plus 5 is 6. 6 plus 8 equals 14. Write down your 4, bundle the 10 hundreds, and move them to the thousands place. 1 plus 7 is 8. 8 plus 6 is 14. Bring your comma straight down. Make sure you have 3 digits after it. 1, 2, 3. The sum is 14,441. Number 2, find the difference. 0 subtract 1. If I have nothing to begin with, I cannot take 1 away. I'm going to go to the tens place, take one of them, unbundle it into 10 ones. 10 subtract 1 equals 9. 1 subtract 6. If I only have 1, I can't take 6 away. I'm going to go to the hundreds place, but I don't have any. So then I need to go to the thousands place. I'm going to take one of them, unbundle it into 10 hundreds. Then I'll take one of those hundreds, which leaves me 9, and I'll unbundle it to 10 tens. I already have 1 10, so together I will have 11 tens. 11 subtract 6 equals 5. 9 subtract 3 equals 6. Bring your comma straight down. 6 subtract 4 equals 2. The difference is 2,659. Number 3, find the product. 81 times 41. I'm going to use an area model for this, so I'm going to get some scratch paper. Okay, I have my scratch paper and my area model. Remember, I have to stretch these numbers out into expanded form. This 8 really means 8 tens. That means the value is 80. I'm going to add that to this 1. This 1 right here is 1 1. The value is 1. Then I have the number 41. The 4 really means 4 tens, and the value is 40. This 1 means 1 1, and the value is 1. And I'm going to add that together because that's how we write expanded form. Okay, remember that when we do the area model, it's length times width. So I'm going to say 40 times 80. I know that because of place value, I can underline these zeros, and I have 2 of them, which means I can put 2 of them in my answer as well. Then I'm left with a basic fact, 4 times 8. If you don't have that memorized, go to your multiplication chart, find the 4, and go over to where you find the 8. And where they meet in the middle is your answer, 32. 4 times 8 equals 32. This rectangle is 40 times 80, which means my answer is 3,200. Now I'm doing this rectangle, and again it will be 40 times 1. Remember that anytime we multiply a number by 1, the answer is itself. So 40 times 1 is simply 40. Now we're down here in the bottom rectangle, and we have 1 times 80. Again, if you multiply a number by 1, the answer is itself, so the answer is 80. And in the last rectangle, 1 times 1. Well, 1 is still being multiplied by 1, so your answer is still 1. Now I'm going to take all these numbers and I'm going to add them up. Make sure to line them up in the ones place. 0 plus 0 plus 0 plus 1 equals 1. 0 plus 4 plus 8 equals 12. Write down the 2. Bundle the other 10 tens over to the hundreds. 1 plus 2 equals 3. And 3 plus nothing equals 3. Count your digits, 1, 2, 3, and put your comma. The product of 81 times 41 is 3,321. Okay, I told you we were going to do number 4 as a challenge. Find the quotient. It's a 2-digit divisor, but I know some of you can rise to the challenge. If this is still too difficult for you, don't worry, just watch. But for those of you who are ready for it, we're going to go ahead and try it out. Remember that you're going to take this number 712, that's your total. That is going to go on the inside in the hundreds place. I divided my area model into 3 place values because this number has 3 place values. This number 89 is still going on the outside. So I'm still multiplying by 100. If I multiply that by 100, I know 0, 0, that's automatically because of place value, right? I know for sure there will be 2 zeros in my answer. And then 89 times 1 would be 89. So I can already see that number is like way too big. Can't do that. So I'm going to take it out. And there will be no hundreds. So I'm just going to move that number 712 over here. And now I'm saying, okay, well, let's start with tens. Again, I know that my answer will have a 0 in it. 89 times 1. Okay, so I can see this number is still too big. It's still more than 712. So that means that there are no tens either. So that's going to be a 0 also. So I'm going to take this number away and I'm going to move it to the ones place. 712. Now because this is in the ones place, I know that the only numbers that can go here is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to think in my head, okay, 89, that's close to 100, right? And this number is 712. So I'm going to try multiplying it by the number 7. Because 7 times 100 is 700. I'm going to try to multiply it by 7 and see what I get. So in order to do that, I'm going to have to do some multiplication over here on the side. I'm going to have to do 89 times 7. Because we're already doing an area model, we're going to do the partial products for 89 times 7. So let me go over here to my scratch paper. I'm going to go up here to a clean spot. 89 times 7. I know this first part is going to be 7 times 9. It's the bottom number times the ones place of the top number right here. 7 times 9. If you don't know that, on your multiplication chart, you go to the 7 until you get to the 9. And where they meet, 63 is your answer. So I'm going to write 63 for my answer. Then I'm done with the ones place. I'm going to cross it off, put a placeholder, and then the next step is to say 7 times 8. But it's not 8 ones, it's 8 tens. So I'm going to write 7 times 8 tens. And the 0 is my placeholder, so it's already going to make me start writing in the tens place. So if you don't know 7 times 8, 10, you can come over here and I follow my 7, and then where it meets the 8, this, where they meet together, that's my answer, 56. So I'm going to go ahead and write that into my problem, 56. Now I'm going to add up those two partial answers. 3 plus 0 equals 3. 6 plus 6 equals 12. Write the 2, bundle the 10 tens, and move it to the hundreds place. 1 plus 5 equals 623. My number is 712. So I have to see if that number is close enough. So I'm going to come back over here. 712 minus 623. Let's see what I get. 2 subtract 1. I can't do that, so I have to go over here to the tens place, unbundle it, and give it to the ones place. 12 subtract 3 equals 9. 0 subtract 2, I can't do that. I have to go to the hundreds place, take 1, unbundle it, and give it to the tens place. 10 subtract 2 equals 8. And 6 subtract 6 is nothing. Now you can see I have exactly 89 left. Do you see that? And my number's 89. That tells me that this can go in exactly one more time. Well, then I can go to this answer I got, 623, and I know that if I added 89 more, because I already multiplied it by 7, so if I do it by an eighth one more time, 3 plus 9 equals 12. Bundle and move over. 1 plus 2 is 3. 3 plus 8 is 11. Write down the 1, bundle and move over. 1 plus 6 equals 7. 712. So in fact, 89 times 8 is 712 exactly. 712 minus 712 equals 0. I have no remainders. So the quotient of 712 divided by 89 equals 8. Okay, I know that was challenging. That's just for you guys who are ready for that challenge. Number 5, find the factors of 15. Remember that if you go to your multiplication chart, all these numbers on the top and all these numbers on the side, those are all your factors, okay? These are all factors. Factors are the two numbers that when you multiply them together, you will get a product. So all these numbers on the inside, they are all the products when you multiply two factors together. So if you need to find the factors of 15, one way you could do it, remember, is to do a t-graph. Write 15 on the top, and you know you always start with 1 in the number, 1 times 15. Okay, then I know that 2 will not go in it because 5 is not an even number. Then I think, will 3 go in it? Let's go over here to our multiplication chart, find the 3. There's 15, so it will go straight up. It will go in 5 times. 3 times 5. Let's see if 4 will go in it. 4, 8, 12, 16, too much. 4 won't go in it. And then I'm back to 5, but I already have 5 on this side. So once you get back to a number you already have, you know you can stop. So these are the factors. 1, 3, 5, and 15. So if we look, our multiplication chart, it doesn't go all the way up to 15. It only goes up to 12. So 1 and 15 won't be on your multiplication chart, but we can see that 3 and 5 are. So your factors of 15, you're going to say 1, 3, 5, 15. And the reason I draw the arrow like this, like a giant U, is that if I draw it like that and then I write my numbers like that, 1, 3, 5, 15, it puts them in order for me and there's no thinking involved. Number 6, write the number in expanded form. So we're stretching it out to place value.
What's up, everyone? How's it hanging? Today, guys, we're going to talk about expanded form. So let's go over and take a look at a few numbers to learn what expanded form is. Okay, guys, I want you to imagine in your mind what a slinky looks like. A slinky is a toy that starts out small but can expand and stretch out. Expanded form is a lot like a slinky. It's taking the number and pulling apart all of its digits so that we can find out the value. Here is the number 358. This number is in standard form. If we were asked to put this number in expanded form, the first thing we need to know is how much are each of these digits worth. The 3 in this number is in the hundreds place, so the 3 is worth 300. Now we have the 5. The 5 in this number is worth 50 because it is in the tens place. The 8 in this number is only worth 8 because it is in the ones place. So if we were to write the number 358 in expanded form, we would have 300 plus 50 plus 8. Just like a slinky that we pull apart, this number is stretched out in expanded form. When you stretch out a slinky and let it go, what does it do? It shrinks back together. Let's do that with this number. Now we have the number back in standard form, and it looks just like a slinky that is not stretched out. Isn't that awesome? Let's look at another example. Here we have the number 417. So how much is the 4 worth in this number? The 4 is in the hundreds place, so we have 400. How much is the 1 worth? The 1 is in the tens place, so it is worth 10. How much is the 7 worth in this number? Since the 7 is in the ones place, we know it is only worth 7. Now, just like that slinky being stretched out, we now have the number 417 in expanded form. It is stretched out to show us what the values of each of these digits are, but we cannot forget to put our plus signs in. When you are writing the numbers in expanded form, you need to remember the addition signs to make the math statement correct. Let's move to this board and look at another number, and let's see if you guys can help me figure out how to write the numbers in expanded form. Here we can see the number 324 in standard form. We need to write this number in expanded form. Let's start by looking at the 3. How much is the 3 worth in this number? 300, because it is in the hundreds place. So we would write down 300. Now let's not forget to write down the plus sign. Now we have the 2. What is the value of the 2? 20, since the 2 is in the tens place. Good job, guys. So we write down the 20 and put down the addition sign. Last of all, we have the 4. What is the 4 worth in this number? Since the 4 is in the ones place, it is worth 4. So the number 324 written in expanded form is 300 plus 20 plus 4. We can also write this math sentence vertically. Let's take a look at what it would look like. Here we see the same expanded form in a different way. If you were to add all these numbers together, you would get 324. Isn't that awesome, guys? Whenever you are asked to write expanded form, I want you to try and think of a toy slinky being stretched out so you can see all of the values of each digit. All right, guys, thanks for being with me today. Keep cool and we'll see you next time.
I taught you a cool trick to do this, so let's go over it. All you're going to do is take each digit and bring it straight down. So I'm going to bring the 4 down, bring the comma down, and then all these digits will become 0. 0, 0, 0. Then I could bring the 0 straight down, but I know in expanded form it's like a large addition problem, so you don't actually have to write 0, 0, 0 because that doesn't change my addition problem. What you could do instead is just draw a line which just shows that that was a 0. Then you go to the next one, the 3, bring it straight down. Remember, it has to come straight down, and this number will turn to a 0. And then you'll bring the 1 straight down, and there's nothing after it. And then all you do is put a plus sign after each number except for the last one. And then you're going to write it horizontally in a large addition problem. And that's expanded form. 4,000 plus 30 plus 1. Number 7, draw a hexagon and partition it into 3 equal parts. Remember, partition just means to put it into parts. But they want 3 equal parts. They have to be equal. Let's go up and remember what a hexagon looks like. You have a little paper on your homework to help you. This is a hexagon. It is a shape with 6 sides. Here is my hexagon. I need to divide it into 3 equal parts. So I'm going to think, how could I turn this into 3 equal parts? Well, I can't do a line like this because those parts are not equal. So that doesn't work. I can't really do, can I do a triangle like I did the other day with the other ones? Let's see. If I do a triangle, that's not going to work. I'm going to have too many parts. What could I do? Can't do it in half like that. Maybe if I, let's see, maybe if I put it like a diamond, that, nope, that's not going to give me equal parts. How can I get equal parts? Maybe if I kind of do the idea that I had where I draw a line and but I skip the vertexes. Maybe if I just adjust my line. Okay, so there's one, and then here's a vertex. I'm going to skip this vertex, but I'm going to draw the line to there. So maybe if I draw another, let's see. So then I have a line there. That works. Look, that works. I have to fix my lines a little. So diamond was kind of on the right track. So it's not perfect, but it's the best I can do freehand. This is definitely it. You can see 1 diamond, 2 diamonds, 3 diamonds. They are 3 equal parts. That was a tough one, and you really had to think. And you know what made me think of this is that, I don't know if you guys have ever played with those tangrams. I'll throw a picture up. But those tangrams, that's what made me think of it. That if you put the other colors on top of the bigger one, I'll throw a picture up and you can see what made me think of this. Number 8, Martin Luther King Jr. was born in 1929. He gave his famous I Have a Dream speech in 1963. How old was he when he gave that speech? We're going to go ahead and use our cubed strategy. So C, U, B, E, D. Circle the units. I have 1929 and 1963. Underline the question. How old was he when he gave that speech? Box the key words. How old was he when he gave the speech? Okay, well, I know that I might box this keyword, speech. The speech happened in 1963, and maybe this keyword, he was born in 1929. Evaluate. What do I have to do? Well, if he was born in 1929 and he gave this speech in 63 and they want to know how old he was, well, I could count all the way up to 1963, but that might take a while. Instead of counting up, I could just subtract the 2 years. So I could take the bigger year, 1963, subtract the smaller year from it, and that would give me my answer. So let's go ahead and do that. I'm going to use my scratch paper, 1963, subtract 1929. Make sure your ones place is lined up. 3 subtract 9, I can't do that, so I'm going to go to my tens, take one of them, unbundle it into 10 ones. I have 3 ones already, that makes 13 ones. 13 subtract 9 equals 4. 5 subtract 2 equals 3. 9 subtract 9 is 0. 1 subtract 1 is 0. So how old is he? 34. But your teacher has to know that you know what 34 means, so you need to write it in a sentence. He was 34 when he gave the speech. Number 9, which fraction is less, 4/8 or 4/5? Well, I see that I have two different denominators. I know from the problems we've done before, and you have this little math help sheet, that if I have two different denominators and I want to see which is less, I have to find a common denominator. Remember, you're going to take this denominator, 7, and you're going to multiply it by the top and the bottom of this fraction. So I have it right here, 4/5 times 7/7. Then you're going to take this denominator and you're going to multiply it by the top and the bottom of this fraction. And I see that here. 5/5 is multiplied by 5/7. We're going to do the same thing. Using the 5, I'm going to multiply it by the top and by the bottom. 5/5. That's what's going to help me keep it an equivalent or an equal fraction, because 5/5 is really like multiplying it by 1. Let's go to our multiplication chart. 4 times 5 equals 20. 8 times 5 equals 40. So that my new fraction is 20/40. Now, I'm going to do the same thing for the other side. I'm going to take this 8 and I'm going to multiply it by the top and the bottom. And remember, that's because it's like multiplying by 1, and it's going to give me an equivalent fraction or an equal fraction. 4 times 8, so go to my 4. 4 times 8, where they meet in the middle, equals 32. And 5 times 8, go to your 5 and your 8, and where they meet in the middle, 40. Now I have two fractions with like denominators, 20/40 and 32/40. Since the denominators are now the same, I can look at just the numerators. Which is larger, 20 or 32? I can see that 32 is larger, so I'm going to put 2 dots next to 32, 1 dot next to 20. Then I'm going to connect the dots, and that gives me my sign. 20/40 is less than 32/40. And since 20/40 is equivalent to 4/8 and 32/40 is equivalent to 4/5, I can say 4/8 is less than 4/5. Which fraction is less? 4/8. Number 10, find the perimeter of the quadrilateral. Remember that a quadrilateral has the root quad because it's just a shape that has 4 sides. To find the perimeter, remember, you add up all the sides. If this side is 3 inches, I know this side will be 3 inches as well. The reason I know that is because this particular quadrilateral is a rectangle, and I know that a rectangle, the lengths are the same and the widths are the same. So if this side then also is 6 inches, that means this side will also be 6 inches. Then to find the perimeter, I'm going to simply add them up. So I'm going to go to my scratch paper and I'm going to say the perimeter equals 3 plus 6 plus 3 plus 6. I can see that 3 plus 6 equals 9. And 3 plus 6 here again equals 9. Then I just have a double. 9 plus 9 equals 18. My perimeter equals 18. You must say the units, inches. So I'm going to write the perimeter equals 18 inches. That's all for today, boys and girls. This was the last page of your Week 7 packet. You will do Week 8 on your own. I hope you have a wonderful summer. Don't forget that we are doing a student pickup on Friday, June 5th at 10 a.m. That means you can come and pick up anything that you left in the classroom, in your desk, your report card, all of that will be Friday, June 5th at 10 a.m. Bye for now.